Now let's take a look at this figure 21-68, and it deals with the classification of area in accordance with 505.5a and b. Now notice the IEC Zone 0 to the left of the illustration. It's kind of publication 79-10 of IEC, and it talks about a Zone 0 is an area in which explosive uh, gas-air mixtures continuously present or present for long periods of time. Example, vapor space inside a vessel or storage tank. Now, a long period of time is anything that's there, over, 1,000 hours or more is considered a long time or long periods of time. But notice Zone 0 is compared to your Class 1 Division 1. Uh, they're about the same as you see there. And our electricians like the divisions because they're used to them. And they know that the first thing they look at to see if they have a problem, and that's 500.5B1 and B2 in the NEC. If the vapor's there during the operation time of the equipment, in other words, it's there all the time, that's easy to detect and understand. And then two, if they're repairing or pulling maintenance type operation in accordance with say an electrical PM manual or NFPA 70B, for example, and there's a leakage that could leak enough that a gas and air mixture could mix together in an explosive range, for example. And then finally, if the equipment could fail at the same time the gas and vapor could be present, an explosion could occur, then that would be a Class 1 division of 1 location. Now notice that's what your Zone 0 is equal to. Now, area in which an explosive air mixture is likely to occur under normal conditions, and that would be a Zone 1. And Zone 1 is when the vapor's there less than 1,000 hours or 100 hours or more. And then they're considering that would be a Zone 1. And notice that Zone 0 and Zone 1 is equal to Division 1, Class 1 Division 1. Now Zone 2, an area in which an explosive air mixture is not likely to occur, and if it occurs, it will only exist for a short time. Now that's what a lot of our electricians not used to zones say, well, what are you talking about, short time, see? Well, that's in the vapor that's there less than 100 hours or 10 hours or more. And naturally, if it's there less than 10, it's not considered a classification by the zones. But notice we're reviewing 505.5B1 through B3 to get these rules. But notice your Zone 2 is equal to your Division 2. Then again, we want to see if we have a problem if we're in Division 2, see? And then if say there's a rupture of a fitting, a joint, a meter, or anything like that, a bleed off valve, whatever it may be, and it starts leaking and could leak into a hazardous condition, and that would be considered a Class 1 Division 2. But basically, they're closed containers. They're closed in such a manner that they only leak under an abnormal type condition, as just illustrated to you. And in Class 1 Division 2, then your mechanical ventilation fails. And that's where you maybe bring in 1 foot of clean air, take out 1 foot of contaminated air, and you reclassify Class 1 Division 1 to Class 1 Division 2. And you let the ventilation bring in that 1 foot of clean air and take out, 1 foot of contaminated air. And then, of course, your Class 1 Division 1 area would be that kind of an area if you didn't have adequate pressure that would have a pressure that would keep the vapor from entering in. If that should fail, and our effectively safeguard measures failed us, then naturally we would need to know that. So this is a classification of an area where we have zones and divisions, and what are the difference in the zones and the divisions, and how do they match up. And that's what this illustration and figure 21-68 is illustrating to the user of the NEC.